Welcome pre-cal students to class today on this wonderful, beautiful Wednesday, November 20th. I hope you guys are doing well. Hope you're ready to learn some math today. Um, let's take a look here at your announcements very quickly. There will be a test on Monday. So if you're not going to come to my house this Monday, would you please let me know no later than Sunday? I would really appreciate that. Remember, when you walk into my house on Monday, I'm jumping down now to announcement number 3. Your integrity sheets must be complete. You must have them filled out and you must hand them to me, and you cannot go home and watch any more videos or do any more homework and get credit for it. Okay? Now going back up to announcement 2, Monday will be the last class until the following Monday. So as I say that, I can hear the cheers coming all the way over from Caleb and Matthew and Corey's house. I know you guys are glad. So we'll take our test on Monday, and then you'll have off Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then look for your first video to start again on that following Monday. I've heard from everyone on the quizzes. Thanks so much. Actually, I've got 3 of you coming over at different days and times, so thank you for doing that. And I'm looking forward to helping you guys, and that's always there. You do not annoy me. Actually, I do get annoyed, and that's when students don't get help or when they don't ask questions. Okay, that's when I get perturbed. Your questions do not bother me, and your needing help does not bother me. Okay, I am your teacher, and I'm getting paid to do a job, and I want to do that well. Grab your notebooks, grab your books, grab your calculators, grab your brains, grab your pencils, and let's get started. Okay. We're going to be looking at some math today that's easy to do. You'll have no problem doing the computations, but it's not super easy to understand. Okay? In other words, why are we doing what we're doing? It's not super easy to understand. I'm not sure why I put this in here. However, the actual math is not hard. I just said that up here. But anyways, do the steps that I give you. Okay, men? And the more you work on this math, the more you will understand it. Trust me, okay? It takes repetition. Now here's what we're going to look at today. We're going to look at vector addition. We're going to start looking at how to add vectors. The date today is the 20th, if you like to keep track of that. And by the way, when I say vector addition, another way to say that is find the resultant. When you are asked to find the resultant of 2 forces, that's the same thing as saying add them together. Okay? So you might want to make note of that. Vector addition. Now I go fast on purpose. You have to back the video up if you need to, okay? I'm going to ask you to add these 2 vectors, okay? Now would you please watch this very carefully, students? Watch what I'm going to do. Watch this carefully. I'm going to add these 2 vectors. So you just kind of listen and take notes how you need to. I want to give you a picture of what you're doing when you're adding 2 vectors, okay? Now, when you're adding 2 vectors, hold on one second, please. When you add these 2 vectors, notice here's what I'm going to do. I take their endpoints and I put them so they're touching like this. Do you see that okay? When you're adding 2 vectors, basically what you're doing, actually that's not what I want to do, and I do know what I'm doing and I apologize. What you want to do usually in a situation like this is you say, okay, the force went from here to here, or the vector went from here to here, and then here to here. So what you do when you're adding 2 vectors is you start at one endpoint like this, pretty easy, and then where it ends, you start the other vector there at that endpoint and go like that. Now here's what you're trying to do. This is very interesting, okay? Here's what you're trying to do. When I ask you to add a vector, to add 2 vectors, you're simply finding this length right here. Okay, not the best line in the world, but hopefully you get the point, okay? There we go. Now, you say, oh, Mr. Earhart, I see how to do it. That's a 90-degree angle right there. Now, hold it. We don't always have a 90-degree angle there. And to be honest with you, we don't even know if that's a 90-degree angle, okay? But the first thing I want you to see is when I ask you to add 2 vectors, what you're doing is this. You're simply taking the vectors and you're putting them in such a way that you go from the endpoint to the arrow and then start from the endpoint and go to the arrow. And then what you're doing next is you're finding this length right here, and that length is what we call the resultant, or the sum of adding these two vectors. Okay? Not too hard to understand. Now, hold on one second, please. Did not mean to do that. Okay, so that's not too hard to understand. When you're adding two vectors, you put them so you start at one, ends here, put the other, and find that length. Now, let's take this a step further. Please watch carefully. Please watch carefully. Take notes however you feel like you need to take notes, okay? All right, now, here's what I just had. Here's the picture that I just had on the previous slide, right here. Now, let's pretend that, see this vector right here? This vector right here? Well, let's pretend I've got that exact same length right here. And let's say I picked it up and put it right here. And then let's take this vector here, the same vector that's there, and let's put it right here. And what you end up with, students, is a parallelogram. Okay? I know my drawing's not perfect here. I know this line should line up a little better, but I think you get the idea. All right? Let me try to slide it in here if I can. There we go. Now, you say, well, Mr. Earhart, what's the big deal? Oh, students, please listen to me, okay? Would you please listen to me? Watch this. Remember what you learned yesterday? You learned that as long as two vectors are going the same direction and have the same length, they're equivalent. So with that in mind, that means this vector right here is equal to this vector here, because they're going the same direction and they have the same length. And that means this vector here is equivalent to this vector here, because they're going the same direction and they have the same length. We learned that yesterday if you're staying on top of your videos, okay? So, if these vectors that I just put up here are equivalent, watch carefully what I can do, okay? I can say, okay, I'm adding, remember, let's go back a page here. I'm adding this vector here with this vector here, right? So that means I'm adding this vector here plus this vector here. Now, if that's true and all these vectors are equivalent, then it really also means this. See if this makes sense. Did not mean to do that. Sorry about that. Then it means, watch carefully, that I can take this vector away and take this vector away. I mean, is this vector right here that I'm scribbling on, that's the same vector as this vector here, and this vector here is the same vector as this vector here. So, Mr. Earhart, what are you trying to show us? I'm trying to show you this. When I ask you to add two vectors, this is so important, please don't miss this. When I ask you to add two vectors and you go like this, and you put one going this direction and one going this direction, I wanted to show you that adding these two vectors right here, like this, and then finding this length right here, is the exact same thing as taking your two vectors and putting their endpoints together and finding this line right here, this diagonal in a parallelogram. That's all I wanted to show you. It's the exact same thing. Okay, so when you're, and I told you it's not easy to understand the math, but the more you do it, the more you'll see it. So what I'm trying to say to you is this. Are you ready? I'm going to try to sum this up for you. Let me look at my next slide. I think I have that. Yeah, have that written down. So with all of this in mind right here, what I just showed you, now please watch. You might have to watch all this and back it up and then take notes however you want to. Now please watch this carefully. So having shown you all of this, I have shown you all of this to finally show you this. Now watch carefully. Here's what I'm saying, okay? I'm going to be really sloppy here. If I tell you to add these two vectors right here, and you've got a vector going like this, and then a vector going like this, you know that what you're trying to find is this length right here. Got it? See it? But also, you can take these same two vectors. Now watch. You can take this vector here, and you can take this vector here, and there's another way to add them. You can put one vector like this, going across this way. That's the bottom vector. And then you can pick up this vector right here, this vector right here, and you can put it going like this. Like that. And then what you can find is, pretend you have a parallelogram, and a parallelogram looks like this. What you're finding is this length right here. Okay? So this line right here that I'm scribbling on is the exact same length as this line here. Trust me, it is. Okay, it totally is. So when you're asked to find the addition or the sum of two vectors, you can write your vector like this, and then going like this and find this length here. Or you can take the two endpoints. Here's the endpoint of this black bottom vector, and here's the endpoint of this right vector, and you can put those two endpoints together like I did here. Here's the endpoint of this vector, and here's the endpoint of this vector right here, and I can draw a parallelogram and find that distance right there. Either way, you're finding the sum. Okay, and that's what I want you to understand today. Now, you might have to back up this video and watch it again, but you know what? I've made the video very short, and I've made your homework very short. So it's really reasonable that you should be able to watch this again if you need to, and to really listen and practice this, okay? So risking being redundant, if you're adding two vectors, and one goes like this, and then one goes like this, you're finding this length right here, okay? Or you can write your vectors like this, and then what you do is you draw like an imaginary parallelogram, like that, and you're finding this length here. It is the exact same thing. It really and truly is. So that's a picture of what we're doing when you're asked to add vectors. Now with that in mind, we're going to do one problem, and then I'm going to turn you loose on your homework. Okay? All right, take some really good notes. We have not gone over this, but now I want to go ahead and show you this. These lines right here mean the magnitude or the length. So the magnitude or length of vector u is 54. Now I know you're used to these being absolute values. They're not absolute values, not when it comes to vectors, okay? The magnitude or the length of vector v is 43. The angle, I'm going to put this, I would encourage you to write this down too. It's very important you write this down. Formed between the two vectors is 150. So that's the two angles that are formed. I want you to find the resultant, or in other words, you're going to add these two vectors together, find the resultant vector, and then find the angle that's formed with the resultant and vector u. Now, I'm not bragging, but if you'll just listen to me and trust me, I can explain this well, and I know you'll understand it. So please watch carefully, okay? All right, here we go. Whenever you're told that an angle is formed between two vectors, whenever you're given the angle that's formed between two vectors, please do not write your vectors like this. Do not write one vector this way and then the other vector going this way. That's not what it means. That's not what it means, and it's not going to work, and you're going to get the problem wrong. Whenever you're told from now on that here's the angle formed between two vectors, what it means to do is to draw a vector like this, and then draw one like this. Now, Mr. Earhart, why did you draw them with this angle here? Well, look, it's 150, isn't it? In fact, actually, I probably should have drawn them a little wider. So we know the angle between the two vectors is 150. So I'm going to draw a vector that goes like this, and then a vector that goes like that. There we go. Now, I don't really care if I've drawn it, if I've drawn this to scale. That's not a big deal to me. But I don't think I've lost you yet. That's pretty easy. And I don't care which vector you call u and which one you call v. I'm going to go ahead and call this one u, and I'm going to go ahead and call this one v. And so I don't think this is too hard to set up. I think you guys are with me. You draw one vector. I always draw one vector just horizontal like this, and then I figure the angle out and then draw the other vector. So there we go. But notice whenever, again for the third time now, whenever it says this angle is formed between two vectors, you want to draw your vectors so their endpoints are touching. Now if you'll go back to the previous examples I gave you, look, whenever I told you the endpoints are touching, here's one vector going this way, and here's one vector going this way, that's when you have to draw the parallelogram and find this length right here. Okay, you're going to have to do it that way, okay, not this way. This addition here only works when you have a vector going one direction and then you pick up there and go another direction like that, okay? So I've drawn my two vectors. They're touching here. 150 degrees is this angle. Now, obviously, I'm going to go ahead and label my vectors. Vector U has a magnitude or a length of 54. So I'm going to label this length as 54. And I'm going to label vector V's length as 43. That's pretty easy. Now, the next thing I'm going to do is I'm going to draw my parallelogram. I'm going to use dotted lines since I'm kind of making this parallelogram up. And there we go. Now, Matthew, I know you've never had geometry, and you're a smart kid, but you might have forgotten what a parallelogram is. A parallelogram is when this side here is parallel to this side here, okay? And this side here is parallel to this side here, okay? That's it. It's a quadrilateral, a four-sided figure in which opposite sides are parallel, okay? So far you guys should be doing good. Now, what did I teach you back here? I taught you whenever you have a vector going like this and a vector going like this, you find this diagonal right here. That's going to be the resultant or the sum of the two vectors. So here's my two vectors. One is going this way and one is going this way. So what I'm going to have to do is find this length right here. I've got to find that diagonal right there. I'm going to label that X. Now at first glance you might think that looks hard or you might not think it looks hard, but here's what we're going to have to do. Oh, by the way, if this is 54 right here, what would this be over here? Sure, 54. So I'd like to show you that you have a triangle here that you can use. Does everybody see this triangle? So what I'm going to do is I'm going to highlight this triangle. I'm going to cut it out and pull it off to the side. So there. So what I did, and let me quickly move this to give us just a little spacer that we need. So what I did is I cut this triangle right here out. Now you might say, Mr. Earhart, why did you do that? Well, here's why I did that, okay? I want to find the length of X, which is this side right here. And if I'm going to do that, then I've got to be able to use a triangle. Now the only problem is I don't have this angle. If I just had this angle right here, which is this angle right here, then I could use Law of Cosines because I know this length here is 43 from this side right here. And I know that this length right here is 54 from this length right here. Are you with me? So, wow, if I just knew this angle. Well, I got some good news for you. You do know this angle right here. Now, Matthew, you've never had geometry, but I give you little bits of information along the way that you need to do the problems. Excuse me, to do the problems that we're working on. And what all of you and those that have had geometry, you might have forgotten this, but in a parallelogram, any angles that are side by side, like this angle here and this angle here, or excuse me, this angle here and this angle here, or this angle here and this whole angle here, or this angle here and this angle here. Any angles in a parallelogram that are side by side always add up to 180. Always, always, always. So if this whole angle right here is 150, then this angle right here has to be 30. Because 150 plus 30 is 180. So now you know from now on how to find this angle. So look what I did. Let's review. I drew my two vectors. I drew the angle that connects them. I will always give that to you. Then I drew my imaginary parallelogram. I drew my diagonal. And then now I said to myself, I'm going to find this diagonal. So I made a triangle, and I got the triangle from right here. Now, I need a new page. Obviously, I'm running out of space. So I'm going to grab this triangle here and I'm going to find the length of X. Alright? So we can use the law of cosines. We learned this a long time ago. So it would be X squared equals 43 squared plus 54 squared minus 2 times 43 times 54. And then cosine of 30 degrees. Now, we did learn this a couple weeks ago, 2 or 3 weeks ago, but that should ring a bell. Now, I know that a great teacher would have this typed in already. I do not, so let me grab my calculator very quickly here, and I'm going to type in, you can type the whole expression in, 43 squared plus 54 squared minus 2 times 43 times 54, cosine of 30 degrees. Okay? And here's what you're going to get. You're going to get x squared equals 743.1780248. And now we take the square root of both sides, and you're going to get 27.26. So I'm just going to round that to 27. So what we've done is we have found the length of x. Now let's go back a page and look at what x is. X is this length right here. So you did it. Let's go back another page. Remember, whenever I ask you to add two vectors, if they're touching at their endpoints like here and here, then the addition is this diagonal right here. So you did it. You just added two vectors together, and what you got was 27. So I asked you to find the resultant, and the resultant is 27. Now I'd like you to find the angle that is formed with the resultant and vector u. Okay, well, here we go. Here's the resultant right here. I'm going to highlight it with a different color. Are you ready? Here's the resultant right here, and here's vector u right here. So it says find the angle that's formed with the resultant and vector u. Well, again, here's the resultant, here's vector u, so you're looking for this angle right here. Now, again, Matthew, you've not had geometry, so if you'll listen and trust me, Matthew, I can help you, okay? Whenever you have two parallel lines cut by a transversal, or intersected by a line, whenever you have two parallel lines cut by a transversal, this angle here will always be congruent to this angle here, okay? So, with that in mind, please watch this carefully. I have a parallel line right here, and a parallel line right here, cut by this line right here. So that means this angle here, like I just showed you over here, is congruent to this angle here. Alright, so when I ask you to find, watch this carefully, when I ask you to find this angle here, which is the angle formed with the resultant and vector u, when I ask you to find this angle here, it's the exact same angle as this angle here. So, remember my triangle I drew right here? That means I can find this angle right here, because this angle right here is the exact same angle as this angle here, which is the exact same angle as this angle here, and that's the angle I'm trying to find. We're going to call this y. So if that's angle y, I'm going to call this angle y, so I can also call this angle y. Now, how do I find that? Well, I'm glad that you asked. Remember, we learned that you can use law of sines whenever you have a pair. And look, I have a pair. I have an angle right here and the opposite side. So if I have a pair like that, I can go ahead and say 27 over the sine of 30. Remember law of sines, guys? You're responsible for previous knowledge, okay? 27 goes over the law of sine, and I'm looking for angle y, correct? Sure. So what side goes with angle y? Or in other words, what side is opposite angle y? 43. So I would say 27 over the sine of 30 equals 43 over the sine of y. There we go. Now, if you cross multiply and divide, you'll end up with this. Are you ready? You'll end up with sine of y equals, now you cross multiply, so you get 43 sine 30 divided by 27. Because remember, when you cross multiplied, you really would have 27 times sine, 27 sine y equals 43 times sine 30, and then you divide both sides by 27, and so we end up with this right here. Now again, a perfect teacher would have this typed in already. I do not. And so I'm going to very quickly type in 43 sine of 30 divided by 27. And I'm going to get this decimal right here, 0.7962963. Now I'm looking for an angle, so I'm going to hit second sine, and then I'm going to type in this decimal number, and I'm going to get 53 degrees. Of course, I rounded it, 52.7, which is 53 degrees. So there, we found angle Y right here, which is 53 degrees, which means this angle right here is 53 degrees, which means this angle right here is 53 degrees. So you did it. You found the resultant, 27, and you found the angle that's formed between vector u and the resultant, which is 53 degrees. Now, I tell you guys all the time, I care about you, I want to help you, I love all the students that I teach, okay? You're going to have to do the homework and practice, okay? So here's the homework. I want you to do 17 through 24, but skip number 18. Why are we skipping 18? Because we just did number 18 right here, okay? So I want you to do page 652, 17 through 24, skip number 18. That's 7 problems. That's very, very reasonable, okay? That's 7 problems. You have a homework video to go along with this. I hope that helps you. I hope you guys have a great day today. Call or email if you have any questions.